Hi, this video is to solve the redundant connection using the DFS depth-first search method. I have another video solving this problem using union find solution. So there are two ways to solve this, two major ways to solve this. So one way to solve this redundant connection is using union find data structure. That will be relatively easy, and I already have a video about that. So please feel free to check my video by search. You can find it in my playlist union find. And now I'm solving it using the depth-first search DFS method. So let's review the problem statement one more time. So in this problem, a tree is an undirected graph that is connected and has no cycles. So you are given a graph that starts as a tree with n nodes labeled from 1 to n, with one additional edge added. The added edge has two different vertices, chosen from 1 to n, and was not an edge that already existed. The graph is represented as an array edges of length n, where edges I equals AI BI indicates that there is an edge between node AI and BI in the graph. Return an edge that can be removed so that the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occur last in the input. So there is only one additional edges added, and we only need to remove one edges. So in this problem, the definition for tree is undirected graph that is connected and has no cycles. So for this example 1, the edges is 1, 2 indicates there is undirected edge connecting 1 and 2, and then edge 1, 3, and then also edge 2, 3. So here we need to remove edge 2, 3 because if we do not remove it, we will form a cycle from 1 to 2 from 2 to 3, from 3 to 1 back. So it forms a cycle. So in that case, we need to return 2, 3. So here, there are multiple ways to break this cycle. You can remove edges 1, 2, 1, 3, and then 2, 3. Here we return 2, 3 because it states in the problem statement, if there are multiple answers, return the answer that occurred last in the input. So that's why we return 2, 3. In example 2, given this edge, we can clearly see that there is a circle formed between 1, 2, 3, 4. So here, since the edge 1, 4 appeared last in the edge list, so we remove this one to break this cycle. And then in that case, we will have an undirected graph that is connected and has no cycle. So let me solve it using the DFS method. So basically define a DFS function. So what am I trying to do for this DFS? So basically for this DFS, I'm x, y. So check. So the purpose of this DFS function is to check if x, y already connected or not. Okay, I can use one line. So basically, in that case, we know the base case if x equals y. So in that case, that means, like, let's say start from x, and then this node will return a base case x and y, they are equal to each other. So of course they are connected, so return true. So a node is already automatically connected to itself. So why we use this base case, you will see it later, because using DFS, what we want is to, start from a node and get to the neighbor. And then let's say if we somehow we can return to itself, let's say in this case, the initial node may be 1, 2, and then starting from 1, 2, we can connect to 2, 3, and then from 2, 3, we can go back to 1. So in that case, the node we returned is itself. So in that case, the x equals y. So we form a loop. Basically, start from x visiting the neighbor and the neighbor's neighbor until there is no more node to visit. And then if we can somehow we can reach y, so in that case x equals y. So in that case we return true. So that's why we need to have keep track of visited. So we do not want to go through the loop over and over again. If we already visit the node 1, we don't want to repeatedly visit the same node. So that's why we want to keep track of the visited. And then we also want to keep track of the neighbors for each node. So basically the nodes connected to each node. So in that case, let me first try to, from collections, import default dictionary. Let me try to keep track of that neighbors as a dictionary. So in that case, we first need to actually get the neighbors for a for x, y in edges, neighbors x equals y, neighbors y equals x. So not equals, sorry, append. And then start traversal. For x, for neighbor in x dot neighbors. So for in neighbors x, if neighbor is not in visited, we add that to the visited. And then we try the DFS neighbor y. So if, let's say, we can return true, so which means we can form a cycle. So in that case, we just return we just break here. We also need to keep track of the results. So in that case, result.append or result neighbor y. So in this case, we form a loop. So in that case, we just return true. And then if we cannot form a loop, we just return false. So here, so I think one thing I did it incorrectly is this neighbors. So basically for this one, I mean, I shouldn't create these neighbors beforehand. So because we want to return the ones that are not actually visited. So in this case, for x, y in edges. Neighbors. I'm creating this list, basically creating the neighbors as I'm visiting each edges. So, and then DFS xy. If DFS xy, I just return xy. So in this case, I do not need the result. So let me take a look at this problem one more time, the solution. So basically for each edges, so we checked every pair in these edges, and then we add that to the neighbors. So we add it to the neighbors. So this neighbor should be added after we finish the DFS traversal. Otherwise, it will always return true because we can always form a cycle. Let's say given x, let's say in this case given 1 and 2, we check if 1 and 2 are they equal, they are not equal. And then for every neighbor in the neighbors x, if the neighbor is not, in this case, the neighbors does not contain anything. So we just skip the entire for loop and we return false. It indicates okay. So this pair has not been connected. So that's the case for xy equals false. So in that case, we just connect them. How are we going to connect them? By assign the neighbors, append the neighbors. So x neighbor is y, y's neighbor is x. So in this case, we create connection between 1 and 2. So here, the second is 1 and 3. So DFS 1 and 3. 1 does not equal to 3. So for the neighbors in neighbors x, so what's 1's neighbor? 1's neighbor is 2. And then 2 is not visited. So we add 2 to the visited list. And then we check the DFS 2 and 3. Oh, sorry, we got 1 and 3. And previously we have 1 and 2. So 1's neighbor is 2. So 2 and 3. 2 and 3 are not connected. So yet. So remember here we are at 1 and 3. So given x equals 1, y equals 3. And we know previously we connect 1 and 2. So x neighbor is 2. And then we check the neighbors for DFS 2 and 3. In that case, it becomes DFS 2 and 3. And then they are not connected. So they cannot form a cycle yet. So in that case, we return false. And then we connect 1 and 3. And now it's become 2 and 3. So 2's neighbor, we know 2's neighbor is 1. And then 2's neighbor is 1. And then 3. We know 3's neighbor is 1. And then that's in that case, we can get the x equals y. So in that case, we return true. So we just return the 2 and 3. So let's try run the code. Okay, so I guess I know why this is not working. I think it's for this visited. So basically for visited, we want to actually start the traversal here. Okay, so the maximum recursion depth exceed. So let me try this one. So let me check this one more time. So this is actually my first time coding this depth first search solution. So I did not practice it before record this video. So that's why I'm having this trouble. Let me check. So basically we have neighbors. We use this one, a default dictionary for the neighbors. And then we have this DFS function. Basically is to check x and y. If x equals y, it means it formed a circle. So we return true. And then we check for the neighbors in every neighbors. If the neighbors not in visited, we add that to visited. And then if the DFS, the neighbor, and y, we just return true. Else, after we try out the loop, we return false. Okay, I think the problem is still with this visited. So, okay, so for the visited, let me check. So basically, for the edges, x, y, in the edges, okay, so I think I made a mistake. So previously, so I wasn't sure about the visited position, but actually, what I should do is actually initialize the visited, reset the visited every time before visit what for each edge. Basically, for each edge, I'm going to check. Okay, if the edge those two nodes for this edge has already in the XY, that they have already been connected. So as I travel through that, check that I need to check. I do not want. Uh, I need to check until they form a circle, and then after that, I need to reset this one. So I think the correct position for this visited should be here. And then I check the XY. If XY is already been connected, in that case, we just return XY. Else, we just connect the two. Okay, let me try run the code one more time. Okay, let me submit it. Okay, so let me recap the solution. So this is the solution for redundant connection, solving it using the depth first search DFS. So in order to solve that, so I create the neighbors to indicate the neighbors for each node. So basically the overall idea for DFS is for x, y in edges. So as I loop through this edges list, so I first set visited equals to an empty set, and then I try to check if this xy has already been connected. If it's connected, I just return this edge because I already find the one. Otherwise, if it's not connected, then I just connect those two by using these neighbors to say, okay, x neighbor is y, y's neighbor is x. So now we connect the edge x and y. We connect the node x, y via this edge. And then with inside this DFS function, so how to check x, y has already been connected. So using depth first search, basically starting from the x and then keep traversing visit the adjacent nodes or the neighbors. Let's say starting from x, if there is an edge connect x, if there is an edge that's already occurred, then we know that this X has a neighbor. So we try to visit that neighbor, and then we also visit neighbor's neighbor. So basically, we're trying to traverse to see, okay, if we can reach Y to form a loop. If we can reach Y finally, then we know that we find a loop by adding the edge x, y. In that case, we can just return x and y. So in that case, the starting point is, let's say, when x and y, if they're equal, we know like starting from x and then trying to visit neighbor, its neighbor, x neighbor's neighbor, and then in the end, we can actually reach this node y. So in that case, we return true. So if not, let's say if x right now x y is they are not the same node. So in that case, we start the traversal. We check all the possible options, basically all the neighbors, all the possible passes from the node x. Basically, try to check every neighbors. If this neighbor has not been visited before, by visited here, it means, okay, this visit is only when we try to check if xy is connected. If the neighbor is not visited before, then we add that to the visited, and then we are trying to check that path to see, okay, if we can reach the node y. If let's say we kind of like reach the end, so by visit x neighbor's neighbor, and then in the end there is no more node to visit because there's no more edges, and we still cannot reach y. So in that case, it's just like after checking all the neighbors, there's no possible path lead to y from the node x. So in that case, we return false. But somehow, if we find one path, we just return true. So basically, this entire DFS function is like, say, doing that first traversal. Okay, starting from x, can you reach y finally? If you can reach y, return true. If not, you just return false. If you like my video, so please feel free to subscribe to my YouTube channel. That would help a lot. And then for this redundant connection, I have another video for the unifying solution.